on Friday. Look in your book.
Yeah, I was testing on that. No way. That was in the morning.
You have one. Have your book back. I'll help you look in your book back. Look in your book back. A spinner numbered 1 through 6 is spun 2 times, and the outcome is recorded each time. Similar problems have been on quizzes and practices. A lot of students we see just put 1, 2, 3, 4, 5, 6. Okay? You have to pay close attention. We're spinning the spinner twice. So you can spin the spinner once and land on a 1. That's the first thing you get. Then you have to spin it a second time, and it can land on a 1 again. Right? That's one outcome.
What's your second?
So again,
Yes.
one of the outcomes, it can land on a 1 and then a 1. That is one outcome. There are 2 things with each outcome because you're doing 2 things in the experiment. It's not just 1, 2, 3, 4, 5, 6. Okay? So then, what you're going to do, you can still have a 1 on your first spin, but a 2 on the second. So you get a 1 and then a 2. You could get a 1 on your first spin and then a 3 on your second spin. You can get a 1 on your first spin and then a 4. You can get a 1 and then a 5. You can get a 1 and then a 6. Can you get a 1 and then a 7? Nope. Oh. No, spinner only goes up to 6. Okay? Well, that's just getting a 1 on the first spin. Now you're going to see what happens when you get a 2 on the first spin. You can get a 2 and then a 1. You can get a 2 and then a 2. You can get a 2 and then a 3. A 2 and then a 4. A 2 and then a 5. A 2 and then a 6. Okay? You repeat the same pattern with a 1 first, a 2 first, a 3 first, a 4 first, a 5 first, and a 6 first. And you will get every single possible outcome. Okay? Again, same pattern, but 3 is going to be first. So 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. Repeat the same thing, but with 4 first. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and then a 4, 6. Write down the same pattern with rolling a 5 first. Write down the same pattern with rolling a 6 first. Okay? This is something very similar to be written on your test. Okay? Well, it won't be that much on your test, but it's good to get a lot of practice in beforehand. The same exact pattern with 5 being first, and then lastly, same exact kind of pattern with 6 being first. I know it's a lot already, you'll have a shorter one on your test. But I'm telling you right now, on your test, this problem, if you write down 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, you're wrong. If that's all your sample spaces is 6 numbers, you're wrong. You're going to miss a ton of points. Okay? This is something like this should be what your sample space is tomorrow on your test. You're going to have 2 things in a parenthesis, and that's going to be your sample space. It might not necessarily be this exact problem, but it will be set up a very similar way. If you're only writing out like 3 numbers or 4 numbers or 5 numbers and that's it, you're wrong. Okay, it should look something like this. So B says, let E be the event of spinning 2 numbers that have an even sum. List all the elements of E as ordered pairs. So just like we did in A. So what you have to do here is go back to your sample space and circle or highlight all the outcomes that fit that description. The 2 numbers add to an even. I'm going to highlight. You can circle or highlight as well. So you just have to go through each thing. 1 plus 1, does that give us an even number? Yeah. And we'll highlight it, you can circle. What about 1 plus 2? No, I guess it's an odd. What about 1 plus 3? Yeah, that's even. 1 plus 4? No, that's an odd. 1 plus 5? Yeah, that's an even number. What about 1 plus 6? No, that's odd. 2 plus 1? 2 plus 2? That's even. 2 plus 3? 2 plus 4? That works. That's an even number. 2 plus 5 is 7, but 2 plus 6 is
11.
8. Okay. And a little hint when you're adding to even numbers, 2 odd numbers add to an even, and 2 evens add to an even. But an even and an odd, no. So really you're just looking for all the pairs that have both odds or both evens as a shortcut. Okay? Or not, just go through and think in your head, well, what's 3 plus 1? That's 4. I'm going to circle it. That doesn't work. That one adds to an even. Nope. That one does. No, that one does. No, yes. No, yes. You just have to go through each one and figure out which one fits that description. Adds to an even. And you're going to circle or highlight it. Okay. Wait, did I miss one? 5, 1, 5, 3. Nope. 5, 5 is the one I missed. Another one I need to highlight. Don't forget 5, 5. That guy right here. 5, 5. Okay, and then 6, 1. Gosh, no. 6, 2. 6, 4, and 6, 6. Go through, circle, highlight all the ones that fit into that description from your sample space. And you'll have a much smaller sample space on your test tomorrow. All those ones you circled or highlighted, you're just going to rewrite here. If you have all the ones you highlighted or all the ones you circled, you're going to rewrite. 1. And you can write them as you go, or circle and then just go back through and rewrite the ones you circled. You'll have a smaller sample space tomorrow.
All over again.
Just the ones we circled.
Even sums. The ones that even sums. So look back at your list, and I should find the ones that add together.
5, 1. Should not be highlighted. Okay, let's clear. No, that didn't work. 5, 1 should not be highlighted. So you highlighted 5, 1, don't. 5, 1. Oh no, 5, 1. Sorry, I'm out of order. The 5, 5 throwing me out. 2, 4, and 6. Huh? All the ones you circle. Again, smaller sample space on your test.
Okay, well, one is no.
Okay. So that is everything that fits into set E. Now in C, we're going to find the probability that the two numbers spun have a even sum. So we're pretty much finding the probability of getting E. You need two numbers that have an even sum. So when you find the probability, you're going to make a fraction. And in A, how many total outcomes were there in our sample space? How many total outcomes? 36. So you go through, you count up all your totals, there's 36 of them. Okay? Well, that's going to go in the bottom. So however many are in your sample space are going to go in the bottom. Then you're going to go through the set of all the even sums. How many are there? 18. That's going to go in the top. Right? So the total possible outcomes of sample space goes in the bottom. However many fit that description, which we found was 18, go in the top. And then you simplify the fraction. What is 18 over 36 simplify down to? 1/2. And what is 1/2 as a decimal? 0.5. So there's a 50% chance you're going to get two numbers that add to an even number. And D, it says, what's the probability that two rolled numbers, fun numbers, no, yeah, fun numbers, have a sum that is not even. Yeah, if 18 out of 36 are even, that means the other 18 out of 36 aren't. One way you can look at it is just do 1 minus the probability that it will be even. So whenever you see this word not, you're just taking the probability that it will and subtract it from 1. 1 minus 0.50 is 0.50. So in other words, think about it, there's a 50% chance that it's going to happen. That means there's a 50% chance that it's not going to happen. Questions over there? One just like it on your textbook. A little smaller.
Again, sample space, you need those. It's not going to be as large, but you need those. Don't just put 1, 2, 3, 4, 5, 6. Put the ones that does. All right? One like tomorrow, study prepared, you'll be fine. Going on to this guy. We're not going to do this one for the sake of time, very similar to the other one. But we do have a couple things to change. This is going to be 65. Huh? It's 70 up there. This one changes to just B.
Yeah.
Oh, no, yeah, it's number 2.
Number 2.
It's number 2. So we got that. What's the first one?
0.09.
0.0. Okay, got that one. 0.09. Point. We'll tell you in a second, guys. Give me a second. What we're doing is we're giving you the answers, guys. If you look, there's an answer key on the back to check your work.
And
It was based off 70. So just a little quick typo. Just change these to percentages. So just write those numbers down. And we try this on a second. Yeah. So just write these down.
Yeah.
When you do this at home, write them down, and we do them at home. These are the answers you should get.
We're not going to go over it now.
Very similar we just said.
This is number 2.
Number 2. Yes, there was a typo, because if you look on the back, the answer keys there, they'd have wrong answers because it was based off 70. No big deal. So these are the new answers they should be. So just write them down. Try them at home. Those are the answers you should get.
There was an answer key?
Yep.
What doesn't Bradley want?
We want them in decimals. That's what we want because we're doing probability.
Well, if your fraction matches the decimal, so you're right.
Yep. All right, write that down. 1, 2, 3. Jot it down. Let's move on to this guy. And by this guy, I don't mean that guy. I don't mean that one either. I mean this one. Number 3 is what we're going to. We are going to do number 3 though. So we're given 2 sets. Give the sets that represent their union and their intersection. Okay. Well, when I do OR, that means I pick something out of A or something out of B. So that is all of the options. So when I do this and write it down, I'm going to do A or B. That's going to be all my choices. So how do we do this? We're going to write down all the options that could happen. So what are my choices out of A if I chose one of those? What numbers could I have picked? 5, 10, 15, yeah, let's do that. So we're going to write this all down. 5, 10, 15, 20. Yeah, what did I say? 25, 30. Okay, those are all the options I could have picked out of set A. What could I have picked out of set B? Yeah, you're right. 3, 6, 9, 12. Would 15 work? Why would 15 work? Yeah, I already have it once. I repeated it. I can't pick that number again. Just with one pick. So 18, 21. I'll just write down these numbers in that set right there. Write down all those numbers, guys. Just what I'm doing. 21, 24, 27. Would 30 work? Nope, because it's already used once. There you go. There's all my numbers. You guys can write it out a long ways. I had to write this to fit on the board. But those are all the numbers, either A or B. Pick a number out of A or B. Any of those numbers work. What about the intersection? It's basically saying, what are the numbers that are in A and B? Well, 30 is correct, thank you. So I'll just say A and B. And as you said, one of them was 30. What's the other one? 15, good. That's it. Those are the only ones that are repeated. And yes, you have to have a little squiggle bracket saying they're in within that area. Pretty easy. Unions, all of them. Intersections, the one they both share. And which one's in this one and in that one? Okay? Ready, steady. Number 4. So, we decided to flip on the back there for number 4. I'll say this, you guys have to do a little bit of reading. I know it's tough. I see a lot of you guys do. You just try to look at the problem, try to solve as fast as you can. No. Read the problem, make sure you're choosing the right information. So of the 312 sophomores at Hayes High School, 162 take geometry, 132 take chemistry, 118 take geometry and chemistry. If a sophomore is picked at random, what is the probability that one of the students takes geometry or chemistry? Stop right there. In word problems, especially in this section, really what you guys should do is, for me, I read the last sentence first. I say, what's this asking for? Well, it says, if a sophomore is picked at random, what's the probability that one student takes geometry or chemistry? If I knew that, I say, all right, there's a key word right here. Or. When I see the word or, what do I need to do? Anytime I see or in these word problems, what do I need to do?
Do a little problem.
There is a little problem, yes. What? The probability, we're going to do the addition probability. Remember that? We're doing the probability of one thing plus the probability of the other minus the probability of both. Oh, let's do so. Well, if I'm looking at this, what's the first thing I'm analyzing in this problem? Again, look at that last sentence. The probability of geometry. Sophomores that take geometry, yes. So I'm going to set that up. I'm going to say the probability of geo plus the probability of the other thing. Well, not in this world, but I don't know. Yeah, you can. There's people that do.
That'd be great.
So the second one is chemistry,
Yeah, chemistry.
and we're going to subtract them both. Let's figure out what's going. How many? Okay, first off, some of these problems are easier than others because I might have the probability already given to me. How do I know these are not probabilities, these numbers up here? Because they're not decimals, right? Decimals mean they're probabilities. These are whole numbers, so we have to find those decimals. It's real easy how to do that. I'm going to take how many it is out of the total number of students. So how many kids take geometry? 162 over how many sophomores are in this class? Awesome. I'm going to add that on to how many students take geometry or chemistry? 1, 3, 3, 2. Still out of 312 minus how many take both? 118. Well, we do need that simplified version of it, so you can't go right away and get your decimal. You could, but we want to see you simplify this. So and we know the denominator is going to be 312 because they're all 312, so that will be 312. So all you have to do really is something. What's 162 plus 132 minus 118? What? 179? Oh, 6. I was going to say, yeah, they're all even. So 176. Okay, great. From the end of time, we need to reduce our fractions. So you guys have to know how to reduce your fractions. So can someone tell me what 176 over 312 is? ADC that if you have a borrowed calculator or math enter. I don't care. What is it? Oh, no, I don't want decimal yet. I'm going to reduce this. Then I'll get the decimal. 22 over 39. 22 over 39 is what my reduced fraction is. But yes, we do want the decimal. And Jessica, what did you get? About 0.56. So about 56%. Of students take one or the other. That's not, I just wrote it out. I just extended it all the way out. I just reduced this. This is equal and reduced down to that. Just know the formula. If it says or, probability of the first one plus the probability of the second minus the probability of both. You have to memorize that. Please. Questions? Moving on. Okay, this guy.
No, go back.
This guy. Next one, number
Okay.
5. There we go.
answer the following. But if you notice in the table, all the numbers are in decimal form, right? They're all decimals. So that means they went through and found the probabilities for us and just recorded them in the table based off the results. So when we have to find the probability of blue, you just go to blue, go to total. What's the probability of just having blue eyes? 0.40. Right? And when you find the probability of having red hair, you go to red, you go to total. What's the probability of red hair? And then for C, it says find the probability of blue and red. Whenever you see the word and, there's no special formula you have to use. Alright? That's only for or. When you see the word and, you just go to blue, you go to red, see where they intersect. What's the probability of blue and red? 0.05. There's no extra work for and, you just look on the table. Questions over those first three? For find the probability of green and black, same thing for C. You just go to green eyes, black hair, go to where they intersect in the table. What's the probability of green eyes and black hair? 0.05. For E, this is where it has the word or. Blue or red. Right? That's where you use that formula we just did in that other problem. Probability of the first plus the probability of the second minus the probability of both. Okay. What's the probability of having blue eyes? You already found it. 0.40. Plus, what's the probability of just having red hair? We already found it. 0.20. Minus, what's the probability of both blue eyes and red hair? 0.05. And then you just plug that into your calculator. 0.40 plus 0.20 minus 0.05. What does that give us? 0.65. Okay. So whenever you see the word or, that's a little formula you use. Probability of the first plus probability of the second minus probability of both. Every time. So again, F, we have the word or. So use that formula. Probability of the first. The probability of the second. Minus the probability of both. What's the probability of having green eyes? Yeah. Green go to total. 0.25. Plus, what's the probability of just having black hair? 0.45. 0.45. To the left, go to total. And then what's the probability of both having green eyes and black hair? 0.05. 0.05. I already found it right there. And then plug in your calculator. 0.25 plus 0.45 minus 0.05. Questions on the next? Whenever you see in the next three the straight up and down line, that means given. That means you have conditional probability. So whenever you have a straight up and down line, you're going to follow this formula, which is probability of both blue and red divided by the probability of the first or second. Second, very good. Probability of red, which is the second thing. Every single time. Follow that formula when you have the straight up and down line. And both divided by the second. Well, what's the probability of both having blue eyes and red hair? I already found it. 0.05. Divided by, what's the probability of just having red hair? 0.20. 0.05 divided by 0.20 is what? How's the decimal? 0.25. Okay. Again, Whenever you have a straight up and down line, you just follow that pattern. Probability of both over probability of second. It's super tempting to say, oh, probability of blue divided by probability of red. This isn't a fraction bar. This means something different. So it's probability of both over the second. Okay? So same thing with H. We have that straight up and down line. So it's the probability of both. What's the probability of having green eyes and black hair? 0.05. So both. Over, what's the probability of the second just having black hair? 0.45. And 0.05 divided by 0.45 is 11. And then for I, probability of red hair given you have green eyes. So probability of both. What's the probability of red hair and green eyes? Here's red, here's green. Where do they intersect? 15. Probability of just green eyes. Green's on a total 0.25. Both over the second. Bye-bye. What do we get? Questions over there? Okay. So when J says based off your results from part B and I, does having red hair have the dependence on having green eyes? Explain. Well, here's part B. Here's part I. Based off those results, would you say that there's dependence or independence? Just based off your results and your understanding of independence and dependence. What do you think? Dependence. Right? Because they're different. Right? The conditional probability, the probability of red given green, is not equal to the probability of the first thing, red. That is a test for independence. If the conditional probability equals the probability of the first, those are independent events, meaning green eyes has no effect over whether or not you're going to have red hair. Right? If they're different, that means there is a dependence. That means green eyes is affecting red hair because they're not the same. Okay? You will have questions similar to these on your test tomorrow.
Moving on. Number 6. So each of the following scenarios given with two events. Explain whether these events are independent or dependent. So A up here. A bag contains 20 white marbles, 15 black marbles. A marble is chosen at random without replacement. A second marble is chosen at random from the bag. Is the second event dependent or independent upon the first event? Why? Yeah, you're right, exactly right. Think about it. If I have white marbles, I reach and I grab a white marble, and I'm holding it in my hand, I don't put it back. And I reach it again. Doesn't the probability change of grabbing a white marble again? It goes down because it's not the same. Since the probabilities aren't the same, we know it's going to be exactly what you guys said. This is going to be dependent. Dependent because of the replacement. Chose, what's that? Picked marble out. Replacement. Changes the probability of the second. Pick the marble without replacement changes the probability of the second pick. As the probability changes, they will be different. What about B? It's exactly the same with one difference. Still have 20 white marbles and 15 black marbles. Marbles chosen at random and then replaced in the bag. Second marble is chosen at random from the bag. Is the second event dependent or independent? Why? because it got placed back. Yeah, it is independent. Independent. It's independent because marble was returned and the probability remained the same. Placed. Probability remains the same. Take it out, put it back in. I still have the likelihood of doing the same exact thing. Now, what other words would mean without replacement without saying without replacement? Think about it like a food item. What could you do to a food item and not put it back? You can eat it. So if you see something about eating something and it changes the probability, that's going to be a dependent situation. If I'm holding something, I grab it, I don't put it back, I keep it, I save it, I put it aside. If any of those words or kind of phrases are used in there, most likely it's going to be dependent. Not always, but the majority of the time it'll be dependent. So you see that, put dependent, give us an explanation. Questions? Okay, next one.
We look at number 7. It says a newspaper did a survey from an adult population and found that 60% texted while driving. They also found that 45% of the adult population has been in a car accident. And 32% of the population was texting while driving and got in a car accident. Is texting while driving independent of being in a car accident? So whenever you have kind of all these percentages and you're asked, well, are these independent of each other? You are essentially using the product test for independence. That look weird. Okay. Where's Phil today? That's the test for independence. Right? Meaning, all you have to do is multiply the two probabilities together, and it should equal the probability of their intersection, their AN. Right? If they're independent. Well, look at that last sentence, like Mr. Carr said. What two things are we dealing with? Good. Texting, and what's the second thing? Car accident. So we have to find the probability of just texting. We have to find the probability of just being in an accident. And if they're independent of each other, it should equal the probability of both. Texting while driving and getting in a car accident. Well, how many was the probability of someone that was just texting? 160. Good. Make sure you change your percentages to decimals. What's the probability of just being in a car accident? 0.45. And then what's the probability of both texting and being in a car accident? 0.32. Well, multiply these two together. What are we going to do? 0.60 times 0.45. 0.27. Does 0.27 equal 0.32? Nope. They are not equal, so make sure you put your slash in your equal sign. Because they're not equal, does that make them dependent or independent?
Not the same dependent. The probabilities change. It's going to be dependent. All right, numero 8. Let's go on this. Events A and B are independent. If the probability of A is 0.48, the probability of A and B is 0.12, what's the probability of B? Huh. Well, you guys are saying, what's going on with this one? Well, really, it's just like the one we just did a second ago. We're doing that product test for independence. Probability of one, what's the probability of the other, should equal the probability of both. Well, let's do so. Let's do the probability of A times the probability of B should equal the probability of both. Let's just fill in our chart. What's the probability of A? What's the probability of A up here? 4/8. What's the probability of B? We do not know. So we're still going to keep that as the probability of B. Do we know the probability of both?
Yes.
Now, this looks very weird. You're saying, I don't know what to do here. Pretend that probability of B is an X. Solve for X. What do you need to do? What is that 0.48 operation-wise doing to the probability of B? So how do you get rid of that? We are going to divide. Divide by 0.48. That's gone. Divide this side by 0.48. And guess what you're left with? You are left with the probability of B. So in your calculators, we can get that decimal. 0.12 divided by 0.48. Gives me this, Alex? What? 0.25. Questions? Very simple one a second ago. This is where you have an unknown. Multiply them together. Divide to find the unknown. Ready, steady. Number 9. Not doing that. Not doing that. No, we're doing that. All right.
If we look at number 10, it says which of the following cannot be the value of a probability? Which one of these cannot be a value? Probabilities have to be between. C, good. The probabilities cannot be bigger than what? 1. And 9/8 is bigger than 1. If you aren't sure, you just do 9 divided by 8 in your calculator, and it gives you 1 point something. You're allowed to have a probability of 100%. There could be a 100% chance that something's going to happen. B, that's less than 1, so that works out. And D, you can have a 0% chance that something's not going to happen. It could be impossible for something to happen. B. We look at 11. It says that the events A and B are independent. Which of the following are true? I know I did a similar problem to this one. If the two events are independent, which of the following are true? Okay. Yeah, C. Okay. Again, the reason why it's C, because if two events are independent, if you multiply them together, it's going to equal the probability of their and. Remember that upside down U shape stands for and. So the probability of A and B is equal to A times B. So they are independent. Never really talked about B. We never really mentioned A or before. We're not sure. And you're going to have a similar problem to this on your test, and you're going to have to be able to identify, oh, yes, that's true, two events are independent. And you have to be able to identify that. Alright? Same thing with 12. If the events C and D are independent, which of the following are true? So if two events are independent, which of the following are true? Very tempting. If this was and, C would be correct. But because it has that conditional, it's not. Think else, what do we know about conditional probability and what in order for two things to be independent? Oh, yeah. Super close. Not A, so it must be B. You are on the right track there because conditional probability, if it's equal to the probability of the first, those two events are independent. Right? Here with A, it's equal to the second. more advantage on others if it's B. So 11 and 12 are things you're going to have to be able to recognize. You're going to be asked some similar type of question, and you have to identify, yes, something like this means the events are independent. Something like this means the events are independent. Okay? Those important concepts on this page right here in your review has those little formulas for you to go back through and study. Has the test for independence, has conditional probability, and then has the addition.
Whoa, guys, not yet. So one more is going to be your test. So you may want to see it. So we have the survey number 16. What is the probability of having, the probability of having a fish was 0.10. Probability of having a turtle and a fish was 0.05. What is the probability of having a turtle given that someone has a fish? Again, this is a statement where you read the last question first, might help you out. What is the probability of having a turtle given that someone has a fish? When you see given, what should you do? It's going to be what kind of statement? A conditional. Remember that vertical bar is conditional. So, conditional again is the probability of both happening. What two things am I analyzing in this problem? Well, look where my given is. What's the first thing that's given? Well, at the front. Turtle. What's the probability of having a turtle and then a fish? Over the probability of the second. Probability of the second being fish. So what's the probability of having a turtle and a fish? Look up here. What's the probability of having a turtle and a fish? 0.05. Over what's the probability of having a fish? Like that. Reduce that out, and you will see the probability of having a turtle given you have a fish. What is 0.05 over 10? 50%.
That's next tomorrow.
You have a fish?